Attention deficit hyperactivity disorder, ADHD, is a condition that affects roughly 5% of children and 3% of adults in the world and causes inattention, hyperactivity, and impulsivity. Often, gene changes combined along with environmental factors to raise the risks of developing ADHD, especially for those with family members with the condition. But MedlinePlus.gov says it is unclear how genetic and environmental factors influence each other to contribute to ADHD. Medline Plus also lists 9 genes that have variations associated with ADHD. One altered protein in the genetic variant associated with ADHD is the dopamine receptor protein D5 in the brain, produced by a polymorphism of the DRD5 gene, affecting attention, memory, and mood. Another change is the SLC6A3 gene that produces DAT, a dopamine transporter protein, which moves chemical signals between neurons, affecting motivation and behavior. These variants both seem to affect ADHD because they each change characteristics associated with ADHD.
Two of the best predictors of risk for developing ADHD in individuals occur on the SLC6A3 and brain-derived neurotrophic factor gene. SLC6A3 is a dopamine transporter gene with 30 different SNPs, and the BDNF gene has a total of 31 different SNPs. Therefore, we would most likely use a SNP chip test for around 60 of these genetic variants to check for these most predictive genes. Specifically, on the SLC6A3 gene, we found that the SNP RS267607068 increases your risk by about 8 times. The different versions of this SNP include A and T, where genotype AA significantly inhibits dopamine transportation to the brain. One other significant predictor for ADHD occurs on the brain-derived neurotrophic factor gene. With 31 different SNPs, we found that RS6265, otherwise known as Val66Met, impacts ADHD directly and increases risk of developing this trait by a slight amount. Genotype AG of RS6265 is responsible for hindering general cognitive ability and slightly increasing risk for ADHD or depression. This result is due to an amino acid substitution of valine to methionine, which alters intracellular trafficking and activity-dependent secretion in neurosecretory cells. Overall, I believe that these two traits greatly affect the risk of developing ADHD and would be very useful to include on a SNP chip test that is specifically designed to test for ADHD risk.
ADHD affects many traits neurologically. Examples include hyperactivity, distractedness, disorganization, forgetfulness, and more. The relationship between RS6265 or VAL-MET and developing individual is linked to ADHD. With a positive test for ADHD, an alternative reach to examine indicators of hyperactivity and lack of attention. Some benefits of testing include a good hyperactivity phenotypic internal liability. With hypothesis-free genome-wide association testing, such as the Gremmel analysis, a multivariate model is used to discover whether or not ADHD indicator dimensions index represent the same genetic liability. According to genetic influences on ADHD symptom dimensions, examination of prior candidates, gene-based tests, genome-wide variation, and SNP heritability results disclose remarkably different relationships between two priori loci and ADHD phenotypes. RS6296 and HTR1B with intended and RS374654 and STAT25 with hyperactivity impulsivity. Adults who receive ADHD diagnosis and receive testing develop better body functioning, stronger confidence, and stronger attention spans. According to studies, previously diagnosed patients with ADHD showed there is good evidence of testing with recommended treatment.
The limitations of SNP chip testing for ADHD are that negative tests might not be completely ruled out by a trait, and that positive tests may not be fully predictive of the trait due to low risk. The SLC6A3 gene has the SNP RS267607068. This SNP's AA genotype increases risk by inhibiting the transportation of dopamine to the brain. However, the extent of this is mostly unknown and is not proved to be a great enough risk to be concerned about. Additionally, the effect of this dopamine transportation does not translate directly to the overall development of ADHD. The BDNF gene slightly increases risk as well with its SNP RS6265. This risk is very minimal and not worth the stress, nor is it fundamentally a key factor in the development of ADHD. Other genes, such as DRD4, are too low in effect and too mixed with contradicting studies to confirm they are a real risk. When discussing the risk factor of these genes or the lack thereof, it is important to note that receiving a positive test for ADHD may be a result of simply having one of these genes. In these cases, the risk could be too minimal to diagnose for ADHD, but a positive test result would say otherwise. While not exactly being a false positive, this result could be unnecessarily worrying for patients who do not necessarily need to be diagnosed.
A positive test for ADHD has several potential effects on one's emotions, finances, and other ethically challenging areas, especially for children who are most likely to have ADHD. A positive test could lead to someone's peers treating them as an outcast, or stigmatization related to employment or insurance. These effects can stretch into familial relationships as well. Hall, Morley, and Ye argue parents and others may lower their expectations for the child's education, personal relationships, or employment, which may mean that a child with an increased risk of ADHD is not encouraged to reach his or her full potential. Additional emotional effects of ADHD testing and treatment are presented by Thomas and Johnson, who assert that ADHD diagnosis is largely subjective, so special conditions such as extra time on standardized testing and medication offered to children with ADHD may not be appropriate and could lead to increased chance of diagnosis and detrimental effects to misdiagnosed patients. Also, genetic privacy is somewhat protected by the United States Genetic Information Non-Disclosure Act of 2008, which prevents discrimination from employers and health insurers due to genetic testing, but does not prevent discrimination regarding life and disability insurances.
Thank you.